Hello everyone, and welcome back to another R tutorial video. And in this video, we're going to wrap up our discussion on using visual variables and changing visual variables from the default settings to improve both the look and effectiveness of our plots using base R and ggplot. And the last visual variable that I want to talk about is size. Now, before we get into code, when we are describing size both in base R and in GGPLOT2, we're going to be using numbers. And it's important to understand what those numbers refer to. So in both base R and GGPLOT2, if we use whatever parameter we call size, because that is different between the two, when we set that equal to, say, 2, right, it's interpreted the same way in base R and ggplot2. And what that 2 is saying is to make whatever we're talking about twice the size of the default standard. Right, so I'll say that again. If we set size equal to 3, that means that's going to be interpreted as make the data 3 times bigger than the default size. And you can go smaller by using fractions. So if you do 0.5, the data will be half the size of the default standard. So hopefully that makes sense. Let's look at some code. So as always, I like to start with base R. I'm actually going to quickly copy the plot from our shape video. So if you don't have that code in front of you, just pause the video really quickly and copy it. So what we're going to do is we're going to delete PCH because PCH was dealing with shape. And we're going to, in base R, use the parameter CEX. So CEX in this case is shapes. And what we're going to do is we're going to set that equal to 2 for our first sort of example. And the way this is going to work is if we run this, and we'll run it down here, you'll see that the plot actually, the points actually look bigger. And just to sort of show you a reference point here, if we remove CEX entirely, remove that period, run that, right, we can actually toggle back and forth. And you'll see it may not be immediately apparent that these are actually twice as big as those are. And we can do 3 and it would be 3 times as big. So in base R, you change the size of the data by using the CEX parameter. So that's in base R. So let's talk about ggplot. ggplot, again, I'm going to really quickly copy our ggplot code from the previous video. So just copying and pasting, just so I don't make any typos or unnecessary typos. So if you don't have this code, again, pause the video and quickly type it in if you're following along. So what I'm going to do is I'm going to delete shape. And as always, I want to just talk for a second about where we could put the parameter. If we put it inside here, inside of AES, inside of the aesthetic function, it would mean that we're telling R that we want size to be driven by a variable in the data set, which in this case we don't. We just want to increase the size of all of the points regardless of what they're doing. So if we're going to put it outside of the aesthetic function, inside of the geom point call. And the nice thing with ggplot is that most things tend to use English words, so it's a little bit less confusing. We don't have to remember CEX or PCH. We can just type in size equals, and let's do 2 here just for consistency's sake. And if we run this, and then we will run this again, you'll see that we have, actually maybe you can't see because let's compare it to what it would be like by default. So this is the default, and then this is the 2. And you can see that we have indeed doubled the size of the points. So that's pretty straightforward. Base R uses CEX. ggplot2 uses size placed outside of the aesthetic function. So let's assume now that instead of having it be uniform across the data set, we actually do want size to be driven by a variable. And this is one of those things where we really lean into ggplot. In fact, I'm going to go so far as to make a comment here and say that base R does not support size driven by a variable easily. Now, it is obviously possible to do this, but it is extremely difficult for two reasons. One, in order to have size driven by a variable, you'd have to have a variable that has the numeric expression, right? 1 or 0 through 100 or whatever sizes you were looking for. You would have to have those in a new column, which would mean going through those same steps that we went through with color and shape. But on top of that, you would have to go through some sort of function, an alternative function, to make sure that those sizes were set up in a way that worked well within the plot. Because you can imagine if you went from 0 to 100, right? 100 size is 100 times bigger than a 1 size. Your plot's just not going to look well when it's done. So there's a lot more work, and it's not easy in any way, shape, or form in base R to do that. What's nice about GGPLOT is that GGPLOT sort of takes a lot of those extra steps and does them internally, so you don't have to worry about them. So what we can do here, and it's actually going to yell at us, and I'll explain why in a second, size driven by categorical variables. So if we copy this here, and we're going to remove the size equals 2 from there, and we're going to move the size inside of the aesthetic of function, because now we want that size to be driven by the variable. And we're going to, because we said categorical, we have to use a categorical variable, otherwise my comment would be meaningless. And the categorical variable that we have in the iris data set is that species. Species. If we run this, and then we'll run it down here so it shows up in the plot tab, you'll notice that we get this warning message. Warning, using size for a discrete variable is not advised. Now, you can see that R did it, right? It didn't crash. And you can see that we do in fact have different sizes, so it didn't have anything wrong with it. What this warning is basically just getting at is a good practice. And in general, it is not a good practice to use size for discrete variables because, this is going to depend on your data. But in this case, if you were to just look at this, right, ignoring even just ignoring the legend, right, you might start to get sort of what I call first impressions, right? Your first impressions about this data would be that Virginica is better than Setosa. And that's not the case, right? It's what we call nominal data, right? When you have nominal data where you don't have any indication of ranking, right? But size sort of by its nature implies a ranking. So that's what this warning is saying. So let's assume that instead of a categorical variable, we wanted to use a numeric variable. Now we're going to copy this code here, and we're going to change from species to, let's do sepal length. This way, as we go along the x-axis, the points should get bigger. Now, I'm not going to run the code right now, and there's a very good reason why. And that reason is if we ran it right now, what R would do is R would try to generate unique sizes for each different value in the sepal length column. And that could be, upwards of 150, right? If all the links were unique. They're not, but if they were, we would have 150 different sizes that I would have to try to calculate. And on top of that just being a very slow process, you also have to remember the fact that ggplot tries to build a legend. And so if it made a legend, it would have 150 different values in the legend, and that's not very useful. So instead, what we're going to do is we're going to include another layer. And this is going to be similar to the layer we've seen before, where we're going to include a scale. And a scale, again, is just a way of saying, okay, you know to take the size visual variable and tie it into the sepal length data variable. Scale tells you how are you going to do that. So we're going to do scale size, because we're talking about a size variable, and then I would recommend using bind. And what bind will do is bind will create essentially an internal histogram and make the size based on those histogram bins. So what I like to do is if you run it without any parameters, it will just sort of pick what it finds to be optimal, and that's certainly an option. And actually, let's go ahead and do that. Let's run that without any parameters. And you'll see that what we've done is we've got 3 breaks here. So anything less than 5 is the smallest, anything greater than 7 is the biggest, between 5 and 6, and between 6 and 7. And so you can see that that kind of works, right? The farther along the x-axis we go, the bigger the points get. Now, I would highly encourage you to check out the parameters of scale size bind, because there are things you can do to tweak this. Hopefully that made sense. I know there was a lot in this video. I encourage you to go back, pause at places you seem confused, and as always, please reach out. Thank you.